This is an example of synchronous technology or other similar technologies. And this is our example case where we have built up a ordered structure that shows a protrusion of a base feature with a block that's extended all the way through to the edge, another solid block that's added onto the right, and then we added our two negative or cut features, one which is cutting this area off here that's straight down. If we look at the profile, it's cutting straight down on this geometry. And we added lastly a whole object here at the end. So in this case, the user wants to make a direct editing change to move our front face out into this region. So the way ST6 works, the user would go to their object that they want to make a synchronous technology modification and tell it to move to synchronous. And in this process, it moves everything that's associated or before in the history up into a synchronous feature and leaves the non-affected features after it as ordered, or any new features that are added in order tree down below. So as you can see here, that allows us to make the direct editing handle change. So if we pull this feature, but you'll notice as we pull this out, you'll see that it's working so far until it hits this area where the feature cuts out. This is because the order dependency is still in place and it doesn't basically give a user a predictable result. The user would expect that when they move this out, it would show up in the region where they're moving it, but since these features still exist here as features that are added later in the history, it still cuts off the object at its plane. Well, there's always a way around it, as you can see. So if in a synchronous, you can go and say, well, instead of just the protrusion, I can actually add more features to that. I can just basically take all these features, or including the cut feature, whichever, and I can add all these to synchronous. Now this is the disadvantage of this. This is a very simplistic object here, which only contains 5 features, but when you get into a very complex structure, you don't know how the order dependency is between all the objects, and you have to either manually move your orders to combine or move to synchronous the minimum amount of features to make your modification, or you end up in moving your entire structure all over to synchronous technology. So this is a limitation that it requires the user to determine what the relationships are and how many of those features it has to move to synchronous to make the modification. So even in this case, yes, we're able to achieve it in this simple example, but there is an impact to the user of when they did that, they lost all their features related to this. And even though we can now get the predictable result, we can also go in here to rotate the faces. For example, we can just select on this face, go ahead and click on the pen, we can get it to change its orientation axis there. And then we can rotate this face. But you'll notice that even though we're making this change, some of the default behaviors of the synchronous doesn't give predictable results as well. Notice the whole is actually maintaining its relationship to that front face and actually moving it down to the part instead of maintaining its extrusion all the way through this block where it initially started with. So it's not really predictable from a user standpoint of what the behavior change is of just that front face being angled or tapered in this condition. So this gives you a very simple example of some of the user's unpredictability of what will occur on these simple changes in ST6. Here we are in IronCAD, and as we started in the other examples, we have a basic part which contains a block base that is extruded, and then we added 2 more solid features, one that extends the length of the block and a small block on the other end. And then we added 2 removal features or cut features that are actually cutting from our original long block and a small hole cutting through our little block. And at this point, we would like to go ahead and make a direct editing change to our object in IronCAD. And how we do that is basically we select down to the feature level, or sorry, the face level in IronCAD, and enable our positioning tool, which is called the triball, which allows users to simply push and pull handles to precisely locate their object, or their face in this case, to the desired location. As you can see, we're about halfway through on our object, and we can go ahead and apply our direct modification. And in this case, IronCAD is very intelligent and gives the user a predictable result. Not only does it make the modification to the structure to give the predictable result automatically for the user, but it also detected that this change didn't require any direct editing to occur. It knew that it was a simple feature that could be used to make this modification, and it left the feature definition alone to make the modification. But let's go back and redo this change, and I'll actually make IronCAD make a direct editing feature. But again, we'll select to the face using our tribal, we'll position it out here, and we'll also rotate the face to basically make a modification that's not in the the definition of the feature. And we'll go ahead and apply that, and you'll see that it detects not only the feature that needs to be modified, but any other features that are related to this feature in order to make that modification occur. And in this case, it doesn't affect any of the other features in the scene, only this block feature is needed to be a direct editing feature to do this. So we'll go ahead and apply that change, and you'll see again it actually combined that feature into a direct editing feature, what we call brep, and inserted it again into the structure where it needs to be in order to give a predictable result. But it leaves all our other features as regular feature definition shapes out here that can be modified, and maintains our definition of other objects, like our hole, for example, is still set to extrude through the face in the location that it was initially defined. So in IronCAD, it gives very predictable results for users and gives them intelligence collection of what faces need to be converted to direct editing, and automatically knows whether they need to be changed or left as feature definitions, and it manages the tree to give them predictable results, which is a very powerful combination that's been matured over 10 years in the IronCAD product.